As we work with customers, we're often hearing that they need to extend what you can do with LLMs. A lot of people from the commercial success of large language models are excited about the possibilities, but they want to know how they can connect it to their data, how they can have the LLMs create solutions and not just be this chat interaction. So today I'm going to be talking about how we can extend these large language models through access to data. So retrieval augmented generation is one of those mechanisms. Agents is another. In either way, what we're doing is in-context learning. So we're bringing in context that the large language models weren't trained on, and we're using that to augment the prompt and allow it to create novel solutions and generations based on your own content, as well as providing tools that allow these models to take actions on your behalf. Because the first thing customers ask for after we start talking about creating these knowledge-driven bots is how we can get them to do the next step. How do we get the human out of the loop and allow these models to take actions on their behalf? So we're going to touch on that as we step through. Now, what we're talking about today is specifically around the Amazon Bedrock implementation of large language models. So we have other hosting models for large language models within AWS, but just to keep it narrow, we're focusing in on the Bedrock option here. And this is a consolidated version of an hour-long presentation that I usually do. So we're going to move pretty quickly through the overview of Bedrock, prompt flows, and knowledge bases. We'll spend a little bit more time on agents, but I wanted to show what you actually do with these agents, because ultimately getting you all interested in being able to deliver on your own use cases is where I find the most value. So we would love to work with you, whether it's me directly or your own solutions architects dedicated to your accounts. We'd love to work with you to deliver these things. These are solutions that I've seen 12-year-olds build applications with Gen AI now. So much of this has been democratized. People outside of IT, people with purely infrastructure backgrounds are able to build and deliver solutions that drive value in their businesses. So first, what is Bedrock? So Bedrock is the easiest way to build and scale generative AI applications. So we provide a choice of leading foundation models through a single API. We also allow you to import your own models or do customization, whether that's teaching it a particular domain through continued pre-training, or if it's doing fine-tuning for a particular use case, like Ron was mentioning earlier when we talk about moving from text into understanding protein structures and how those genes may be expressed in what the implications of a particular protein may be on a system. Those are things where we have to fine tune because it's no longer just predicting the next token of text in a structure. But today, what we're focused on is just supercharging these text-based large language models. So we do that through retrieval-augmented generation, where we connect to your data sources. Bedrock has a fully managed solution for that we'll touch on to get the augmented data from your systems. We also have Bedrock agents, which allows you to execute these complex multi-step tasks, provide tools to the LLM so that they can take actions based on the context. And this is all wrapped in the security and privacy that you would expect from AWS. So taking a quick look at the different models, this is something where different LLMs have different strengths and different capabilities. So you can see a number of third-party models as well as first-party models that we provide through Bedrock. This is a subset of the models. You can understand kind of where you want to use them based on these header columns here to see what the functionality of those different models are. But even within a family of models, there are a lot of different options. Bedrock provides the option to do evaluations to identify which models perform best for your use case, but you can also work with your solutions architect in order to steer you towards a particular model for a use case. That said, if you want to do these evaluations yourself, it's also quite easy to test and iterate and try the prompts, try the RAG and the agents with different LLMs, because it's all behind the same API. One way to do that will be with the Bedrock prompt flows. So with Bedrock prompt flows, you're able to leverage this drag and drop interface in order to build out your application. So moving beyond, a single prompt and an output and being able to string things together. The example that we show here is a very simple one where a prompt comes in. If the prompt is talking about Octank, then it goes to an Octank knowledge base to augment the response. If it's not talking about Octank, it goes to an enterprise prompt that has some instruction sets in there in a particular LLM to respond. This is because oftentimes when people build a very focused bot, they'll find that people will ask it all sorts of things. I build a bot that's purely focused on checking order status, and they'll ask questions about the company, and they'll ask, help desk questions or anything else. So oftentimes being able to build out this flow within your bot visually so that it can handle these corner cases and redirect them, whether it just says, simple fixed response, or if you actually over time add additional capabilities based on what you see your users asking. It's something that you can do visually, and you can see here that there's an actual section where you can test on this. So if you've got 10 different versions of a prompt that goes through different models or 10 different knowledge bases, you can drag and drop them, switch them out, see which ones work best. This is all versioned and aliased. So if you do have different versions you want to test, access them through the alias. So really easy to build relatively complex solutions. This also works with agents. So we're going to touch on agents in a moment after we do our quick overview of what knowledge bases are. So knowledge bases is our fully managed retrieval augmented generation, or RAG, solution within Bedrock. So this does everything from connecting to your data sources in Confluence or SharePoint, brings in the data, does the advanced parsing. So if it's got images, it'll create the text-based representations, tables will be translated into Markdown, that sort of thing, so that they're prepared. It'll do the embeddings, it'll do the retrieval. So all you really have to think about is pointing this at your source data. It gets pulled in, and then you pass in your query. The query will go to the knowledge base, retrieve the data, and then augment your prompt. So you're not retrieving the data and then doing the prompt augmentation on your own with LangChain or something similar. You're able to just make this single API call. It will do the retrieval and the generation. So it is one of those accelerators that makes it really easy to start working with RAG and AWS. But what if the data is not in a static format where you can just index it and retrieve it? It's something dynamic where, based on the user's prompt, the context that comes in that query, the agent needs to formulate a SQL query and pass that query into a database, or it needs to make an API call to pull in this data. That's where agents comes in to assist with those use cases. So agents is similar in that it's that single stop. You accept the prompt, the query that comes in, it does the chain of thought, and it'll look at all the tools that are available, figure out what it needs to do, and then it'll call the right tools. And we'll look more at that as we step through. But before we do that, every time I have these conversations, customers want to know about the security. There's a lot of uncertainty when it comes to interacting with large language models. So I typically start out just saying none of the customer data is ever used for training or improving the large language models. The data that you pass in is private. It's encrypted in transit and at rest. We're not using that data or providing that data to the third-party model providers for their model training. And it's not something you have to take my word for it. You can go into Artifact in your AWS account and pull down all the auditors' reports. We have support for GDPR, SOC, ISO, etc., so that you can build your generative AI applications even using the sensitive data in your enterprise. So let's jump into the agents. So in a simple sense, an agent is going to be made up of a few components. So you're going to have instructions, you're going to have the actions and knowledge bases, and then you're going to have a foundation model that it uses. So a user says, do this for me, and you get the results. But if you actually look into it, you don't have to have all those extra tools. The simplest agent is really just going to be a set of instructions in a large language model. So in this case, a joke bot. Why did the AI go to school? To improve its learning rate. And it is also prompted not to answer anything else. So you can use the prompt instructions in order to steer the model so that it won't address off-topic problems. But getting into a more practical use case, you typically, if you're going to build an agent, you want to add some actions. You want to add some capabilities of what that can do. So in this case, we're going to add in meeting actions where it can list the meetings of a particular user and query the action items for that meeting. And then we're going to give it the capability to also send emails and get teams. And we'll look later at how you actually express this within agents. But the final state is when somebody comes in and asks for the action items, it will list their recent meetings, get the action items for that meeting, and pass them back to the user. And there's memory built into these agents. So when the user says, send them to my team, it knows that them is the action items from the meeting. And it also uses the other utility action. So whenever you build these out, you don't have to program that based on this, make this call. The reasoning within the large language model decides that when you ask a question, it needs to list the meetings, or when you want it to send an email, it uses those utility actions to send the emails. So it takes all that programmatic logic out of it and just does it through the LLM's reasoning. So you focus on creating the actual tools that do the actions for it. So in this case, sending the specific team members the specific action items from the email, or sorry, from the meeting. Now, you can also leverage knowledge bases in conjunction with these actions. So in this case, if we have a knowledge base where we've got some vacation policies in there, users can come in and ask. But as I said earlier, whenever we start out with these knowledge-based use case, people often want to extend them and give them actions. So after you've got your knowledge base bot up and you're comfortable with using that and your users are adopting it, you can build a V2 where you add in some actions. So in this case, the action is just allowing them to request vacation. So this may be something that you picked up from the logging and the traces that after people ask if they have time to take off, they often want to request that time off, or it could just be something that you phased out from the beginning. But in this case, you can ask the questions. Based on the question, it looks up the answer in the knowledge base. And then when it asks for an action, it knows to use the action in the bot. All of this is built on top of your existing enterprise resources, so you're not building out new data repositories. As I mentioned, knowledge bases will connect not only to something like S3, where you may be processed in stage documents, but it'll connect to the raw data sources in your SharePoints, in your Confluence, in Salesforce, and it'll pull that data in, do all the pre-processing for you, and then providing it in the knowledge base. The agents allows you to connect to existing microservices. So if you have a vacation microservice, it can make those API calls for you. But also if you just have a database and you don't have a service on top of it, you can have the LLM formulate the SQL query and pass that to the database directly. So you don't have to build out new silos of data. You don't have to build new controls. Each of these agents has its own IAM policy, its own identity that can be used to provide least privilege access into the system. Ultimately building out bots that can create solutions. So let's look a little more detail at what's actually happening as these interactions happen. We provided a prompt in or a task into the agent. The agent is going to formulate a chain of thought based on that task. So it gets the prompt, the conversation history, the tools that are available to it, the instructions that you've provided, as well as the task that comes in. The large language model is going to reason across that. It's going to generate a chain of thought. These are the steps that I need to take. I need to look up the information in the HR knowledge base. If they have the ability to take time off, I need to make an API call to see what their current available time off is. And then if it's available, I need to make a call to the service to actually request the time off. So it formulates this chain of thought. It will then make the actions that are listed in that chain of thoughts, generating an initial result. That result is passed back to the Bedrock agent that then passes the result in the task to the model again to say, this is what I got from my first pass at this. Is this solving what the user requested? And if it is, passes it back to the user, all good. If it's not, it will formulate a new chain of thought. Well, you don't actually have time off, but it says there's some sick days. Maybe I will check if they have sick days, and it'll do a whole nother round of this before it passes the final response back to the user. So what this looks like with real data, you're going to decide what you want this agent to do. I want it to send a reminder to policyholders with missing docs, and I want to include the requirements. So you need to create some different actions. You need to create a knowledge base with the document requirements, but you'll have this initial set that you set up. So we'll create some actions, get claims, compile the missing documents, search the knowledge base for the requirements in that document, and then send out the notifications. So whenever the requests come in, it will decide what it needs to do based on the request. It may decide that it only needs to compile the missing documents because the user's prompt is what documents are missing on this claim, or it may need to chain all of these together in order to create the solution. But it's going to just make those decisions based on the instructions that you give it, as well as just the reasoning capabilities within the LLM, allowing you to create a solution that does more work than just look up information. It can actually decide what it needs to invoke, make those invocations, and then based on the results it gets from each invocation, adapt the further steps that it takes in order to deliver on the business value that you're looking for. Now, when you actually set these things up, it's not a black box. You can see the reasoning that the model does in plain text. So if you're using the console to test this out, or if you're making SDK calls in order to interact with something that you deployed, you can see the full chain of thought. So in this case, you can see the different steps that it's saying to take, call the get claims, check if I have pending documents to send the reminder, et cetera, et cetera. And as you look at this, it's all plain English. As Ron said, it's not something where you're building out complex programmatic logic. You're writing it out in plain text. The model is explaining its chain of thought again in plain text. There's a little bit of markdown to make it easy to process and automate some of the processing of it. But if you see something and its steps aren't logical, you can just go into the prompt and modify it. So you can update these instructions so that it does come up with the appropriate chain of thought to take the actions, call the APIs that you want, and then deliver on your business value. So again, plain text, edit in English, and then run another test to see if you get the results. Something very easy for people of all different backgrounds, all different skill sets to iterate and build these agents. Now, looking at a few examples of what you can build with this, because again, this is my favorite part, is when people of all different backgrounds come and say, I want to do this thing, whether it's some IT person or whether it's a PhD in microbiology, they all seem to have these use cases of, hey, I want to do this thing. How can I do this with knowledge bases? And I would encourage all of you to either reach out directly to me or to somebody else at AWS, and we would love to work with you on a POC. There are lots of different flavors, from more low code, user friendly than Bedrock to full code. We can build a whole set of different solutions. But I do want to just take a look at a few simple solutions to hopefully spark your imagination on what can be done. So here we're starting with a simple laptop support assistant. In this case, the customer maybe has a support wiki that has all the information, common problems database, and we're going to provide those knowledge bases as well as some agents that it can use to look up the support history. So maybe it's going into ServiceNow and seeing if you have tickets in the past. So when somebody comes in and says, my laptop is dead, can I get a new one? It's able to go in, look up the support wiki, and see that the policy says, if you've had more than 5 service interrupting issues in the last 6 months, you qualify for a replacement laptop regardless of the issue. Now it knows it needs to make a history request to support to see how many downtime issues the user had. And if it qualifies for the replacement, it can actually place that order replacement. And this is something that you can easily implement because most of us have these tools already. You have the knowledge built into your support wiki. You've got a ticketing system that you can interact with, and maybe you need to orchestrate a laptop replacement API. But overall, something that's relatively easy to put together and deliver a quick lift for your team, get some capacity back to work on other things. But I don't want you to think of all of these as chat interactions. A lot of the most interesting LLM use cases I work with have no chat front end. It's just a bot working on your behalf in the background. So this can also be done with ticket triage. So whenever a ticket comes in, we're going to automatically process that ticket. and we're going to look at the user that requested it. Are they a VIP? Does that impact the policy of how I route this ticket? I'm going to look at the skills profiles, and I'm going to make a judgment based on the skills profile, the request, the VIP status, and I'm going to decide who to send the request to. So again, you're not creating all of this logic. You're not trying to figure out what the best skills match is, who's got the best capacity, all of that in your programming logic. You're expressing it in plain English, and you're allowing the model to reason against that, to make those decisions and triage those tickets. Now, over time, this may be something where you want to build a V2. And in addition to just doing the triaging and routing, maybe there are some common problems that come in. This account is locked out. It makes an API call to see if the account's locked out. It looks at the history, and maybe it'll automate the first unlock for the user, or other common tasks you can just build out and continue to extend. So building lots of these small agents can do lots of things, becomes a very iterative approach where you can move very quickly to get initial value, but then extend the value over time that these different bots can deliver. It also works well for production assistance. So when we're looking at productivity, we have a lot of very busy knowledge workers out there, and being able to just give them maybe 10% of their time back is a huge value add to the business. It's a low risk situation because you have that human in the loop that has the domain expertise that can help you build fully automated solutions. So product reputation, maybe that's something you still want going through a marketing person, but you don't want them to have to do all the work. We want to give them a draft of what the response is going to be, and maybe we allow them to click approve, and then it routes out to the post. Or maybe they make some changes and then it routes out to the post. So you could create that, again, providing the information, providing the tools in order to post those comments. And this may be kind of a mix between the chat interaction and the bot actions that you take. And then finally, one that I see a lot of use cases on are around connected devices. More and more, almost all the devices that we interact with have some sort of connectivity, some of them more robust than others. But when you have that connected data and you're interacting, whether you're the subject matter expert or you're the end customer, it's great to bring that into the context of the prompt, so that when I ask, why the temperature is out of range on my samples refrigerator, it's not just going to look up in the database and say, here's 5 reasons why it might be. It's going to say, here's 5 reasons that it might be. I can check these 3. The door has been opened for more than 45 minutes, and it makes the call to the telemetry. It finds out the door was open. It provides a response that says, hey, at these times the door was open, just leave the door closed, nothing to worry about. But it may also say your voltage is low, the compressor is not able to keep up. It looks up where spare parts are. It figures out when it can dispatch a tech. It goes to the service app. It sends it out, and everything in between. So you can create these really interesting solutions on top of those connected devices. And I've seen people that use them purely for triage and kind of informing their support tasks, people that have exposed this out to their end users as a fully orchestrated solution, and everything in between. But it is one of those things that is very extensible. And it's something that you can start small. Maybe you just start with a knowledge base and a troubleshooting guide, and in an afternoon you've got an app up and running, and then you start iterating and adding on based on your experiences working with the solution. All right. So appreciate the time, appreciate the attention. Just want to thank you for taking a little bit of your time. I know everybody's busy. Would love to spend some time with all of you, or any of you that are interested in building these solutions. But if there aren't any questions, or maybe I'll open it up to questions if anybody has any on Amazon Bedrock.